Alright, so the Pythagorean Theorem. And before anyone asks, yes, that is how you spell it. So, the Pythagorean Theorem. So, before we got out of school, we were talking about geometric means and right triangles, and we got to the point where we had some things that were going on with our square roots and our geometric means. So we're just going to take those and we're going to manipulate them a little bit. So instead of writing this as, instead of writing this first one as a equals the square root of xc, I'm going to square both sides. And we're going to call that a squared equals xc. So that squared is just going to cancel out that square root over there. So we're squaring this, we're squaring that. That square root is gone. So now we've got this. And we're going to do the same thing with our b equals the square root of yc. We're going to square both sides. And that's just going to cancel out this square root over here. So now we've got a b squared equals yc. Okay. Now we're going to take those and we're going to add them together. And a little bit of substitution, we're going to have a squared plus b squared equals. And instead of that a squared, we're going to have an xc. And instead of that b squared, we're going to have a yc. Okay. And the next thing we're going to do is we're going to take that side over here and we're going to factor that. So we're going to take a c out of both of those. If we take a c out of an xc, we've got an x left. If we take a c out of yc, we've got a y left. But if we're looking up here at this triangle that we drew, we have x, we have y, and we have x plus y is that whole side, which is c. So if we substitute that in there, x plus y is really c. And c times this other c is c squared. So that gives us the Pythagorean theorem, a squared plus b squared equals c squared. This is not news. This is not a new thing. This is a thing we've been using since like 8th grade, but now we've actually gone through and figured out, okay, well, how do you get that? So that's the Pythagorean theorem. So now we're going to look at some examples of, okay, how do you use that? So I'm going to go to my next whiteboard over here. And the first thing we can do with that is we can just use that to find a missing side of our triangle. Now, the thing you want to watch out for here is that C is always your longest side. So the other two can be A and B in any order, but your longest one is C. So I'm just going to go and call this C. And we're going to look at this triangle here on the left first. So now what we're going to do with this is we're going to plug it on into the Pythagorean theorem and say I'm going to call this A and B. Actually, I'm going to use a different color here. Hang on. Oops. So I'm going to call this A and B. And we're going to plug those in. So we're going to say 5 squared instead of A squared plus 12 squared instead of B squared equals C squared. So A squared, B squared, C squared. And now it's just some algebra. So 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. And then if we want to get rid of that squared, we're going to square root it. So I'm going to square root this. I'm going to square root that. And we get C is 13. Okay. Now, we're going to do the same thing over here on this one, but instead of looking for C, we're looking for either A or B. I'm going to call it A. You can call it either A or B. A and B can be in either order, but C has got to be your longest one. So I'm going to call this longest one over here C. Okay, but we're doing the same thing. So I'm going to have A squared this time, plus B squared is going to be 17 squared, so this is B. And then over here, I'm going to have a 20 squared, which is my C. Oops, there we go. So A squared 17 squared, and this is where I'm going to pull out my calculator because I'm not entirely sure what 17 squared is off the top of my head, and that is 289. Alright, 20 squared, this one I know, that's 400. Okay, now we're just solving for a. So we're going to subtract 289. 289. We're just using a squared equals 111. And the square root of 111 is... calculator. There we go. Square root. Where's my square root? There's my square root. Square root of 111 is about 10.5-ish. So A is about 10.5. Alright, so if you're missing any side of your triangle, you can find the other one. And again, as long as this is a right triangle, so this only works if you got right triangles, don't use it on any other triangles. We'll get to some other ways to find things that aren't right triangles later in this chapter, but for now, these are all right triangles, only use this for right triangles. And the only thing to watch out for here is whether you're looking for C or whether you're looking for either A or B. So C is your longest side. If you're looking for C, just plug it in and just PEMDAS that thing. If we're looking for either A or B, you got a little more solving, but this is just algebra. You guys know how to do that. Okay, now, all that stuff is stuff that we've been doing since 8th grade. Hopefully you remember how to do that part of it. Here's the new part. So if... let's say we don't have a right triangle. Let's say we've got this triangle. And we take this angle and we make it a little bit smaller, but we keep this side the same. So this side's going to be the same. This side's going to be the same as itself. Think back to the hinge theorem back when we were talking about triangles. If we have two sides that are the same and I make the angle between them a bit smaller, that's going to make this side smaller. So if we make that angle smaller, the side across make it smaller. Again, as long as those two sides are staying the same. So if we make that angle smaller, we've got ourselves an acute triangle instead. So if we have an acute triangle, then instead of a squared plus b squared equals c squared, we're going to have a squared plus b squared. And since we made c smaller, c squared is going to be smaller than a squared plus b squared. So if it's an acute triangle, a squared plus b squared is bigger than c squared. Okay. Now, take a guess what's going to happen if we make it an obtuse triangle. Yeah, the opposite's going to happen. So if we take that angle and we make it bigger instead, again, if we keep this side the same as this side and this side the same as itself, if we make that angle bigger, that's going to make this side of our triangle bigger. So big it's going to go off my little whiteboard here. So if we make this an obtuse triangle, then instead of a squared plus b squared equals c squared, a squared stayed the same, b squared stayed the same. This side got bigger. So that side, c squared, is going to be bigger than a squared plus b squared. So if it's an acute triangle, a squared plus b squared is bigger than c squared. If it's an obtuse triangle, it's smaller than c squared. And that's something you're probably going to want to pause the video and write it down for future reference, because that's going to be important. And the big thing is just not flipping around which one's which. So if it's equal, it's a right triangle. Bigger than c squared, it's acute. Less than c squared, it's obtuse. Now, what we can do with that is if we have three numbers, we can go through and we can figure out what kind of triangle it's going to make without even drawing out anything else. So if we have, say, our three sides are 12 and 16 and 20, what we're going to do is we're going to take that and plug those in for a squared, b squared, c squared, and see which one of those three triangles we end up with. So if I've got 12 squared plus 16 squared, and I want to know, does it equal 20 squared? Is it less than 20 squared? Or is it bigger than 20 squared? So 12 squared is 144. 16 squared is 256. Yes, I did pick nice numbers on purpose. And 20 squared is 400. 144 plus 256 is 400. 400 equals 400. So this is a right triangle. So if a squared plus b squared equals c squared, it's a right triangle. Yay. Now, technically, one thing I didn't mention earlier is in order to be a triangle in the first place, think back to what we were doing with triangles before, any two of your sides have to add up to more than your third. Because otherwise we get a little thing here where we got one long side, so I make this 1, and I make this 1, and I make this other side 8 or something. That's not going to give me a triangle. So in order to be a triangle in the first place, these two sides, whatever they are, have to add up to more than your third, and that's got to be true for all three pairs of your sides. So we're just going to double check that first. Make sure, okay, 5 plus 7 is 12. 12 is bigger than 9. This is a triangle. We're good. Now we're going to figure out what kind of triangle it is. So I'm going to go and plug in 5 squared plus 7 squared. And I want to know, is it bigger than 9 squared? Is it equal to 9 squared? Or is it less than 9 squared? So 5 squared is 25. 7 squared is 49. 9 squared is 81. Okay, 25 plus 49 is 74, which is less than 81. So if a squared plus b squared is smaller than c squared, that makes it an obtuse triangle. Okay, just a couple more examples of that. If we've got 4 and 10, remember again, we want to make sure it's going to be a triangle first. So if we have 4 plus 4, that's only 8. That's not bigger than 10. So this is just not a triangle. And if it's not a triangle, then you don't have to go through and figure out whether it's not an acute triangle, not an obtuse triangle, not a right triangle. It's just not a triangle. Okay, one more. So let's say we've got 5 and 6 and 10. So same sort of thing. We're going to plug them in for A, B, and C. And again, remember, C is always going to be your biggest one. So I went ahead and wrote all of these nicely in order. I'm pretty sure all the ones in your book are nice and in order too. But if they happen to not be, C is always going to be your biggest one. So we got 5 squared plus 6 squared. And I want to know, is that bigger than 10 squared? Is that less than 10 squared? Or is that equal to 10 squared? Okay, so 5 squared is 25. 6 squared is 36. 10 squared is 100. 25 and 36 gives you 61. 61 is less than 100. So this is another obtuse triangle. Oh, that's my cat. Okay, there's an obtuse triangle because a squared plus b squared is less than c squared. So that's pretty much what's going on. Again, if you have questions, comments, feel free to let me know. Either throw a comment in the comment section if you think it's something that other people are going to want to know, or if you want to email me separately, that's fine. Assignment is in the comments, and that is going to be due on at the end of the week. So if we get back to school next Monday, it'll be due then. If not, that's just going to be due end of this week. Try to get it in before then. Alright, so that's that, and have a good day.